Hey guys, in this video we are going to be talking about matrix multiplication, and there's a big difference between matrix multiplication and regular old multiplication because this is not commutative. For instance, in example 1, the product of A times B is not going to be the same thing as the product of B times A. Also, not all matrices can be multiplied together. It will only be possible to multiply two matrices together if the number of columns in the left-hand matrix is equal to the number of rows in the right-hand matrix. Matrix A has 3 rows and 2 columns, and matrix B has 2 rows and 2 columns. As a beginner, you might find it helpful to write down the dimensions of the matrices to see if the multiplication itself is possible and to see what the dimensions of the resulting matrix will be. I want to point out here that if we were to multiply B times A, that would be undefined because the number of columns in B does not match the number of rows in A. So the product of matrix A times matrix B will be a 3 by 2 matrix. Now the process for multiplying matrices together is very different than adding or subtracting, because with addition and subtraction we were just combining the two numbers that were in the same relative location in both matrices. That's not the case with multiplication. The first thing we'll want to do is write down the dimensions and make sure that the multiplication is possible. Since the left matrix is 2 by 2 and the right matrix is also 2 by 2, we have matching columns for the left and rows for the right, so it's possible. And our answer is also going to be a 2 by 2 matrix. You should remember from the previous lesson that we can describe the location of an element within a matrix by the row number and column number. So the elements in our resulting matrix will be 1, 1, 1, 2, 2, 1, and 2, 2. And we can actually use these locations to help guide us through the process of finding the number that goes in that spot. For example, 1, 1 means we're going to multiply row 1 by column 1. So the process for finding element 1, 1 in our matrix answer is to multiply the elements of row 1 from the left matrix with the elements of column 1 from the right matrix and add those products together. So for that first element of our product, we're going to take 1 times 3 and add that to 4 times negative 1, which gives us negative 1. For element 1, 2, we're going to multiply the first row by the second column. So first number times first number plus second number times second number, which gives us negative 8. For element 2, 1, we're going to multiply the second row by the first column. So first number times first number plus second number times second number, which gives us 7. And for element 2, 2, we're going to multiply the second row by the second column. So first number times first number plus second number times second number, which gives us positive 2. Now example 3 is going to have more calculations than example 2 because there are more columns in that second matrix. Now we know that we are able to do this multiplication because the left matrix has 2 columns and the right matrix has 2 rows. Since those numbers match, we're able to do this, and our resulting matrix is going to be a 2 by 3 matrix. So for element 1, 1 of our answer, we're going to multiply the first row of the left matrix by the first column of the right matrix. So we'll do the first number times the first number plus the second number times the second number and get negative 7. For element 1, 2, we're going to multiply the first row of the left matrix by the second column of the right matrix. So we'll have first number times first number plus second number times second number, which gives us negative 1. For element 1, 3 of our product, we're going to multiply the first row of the left matrix by the third column of the right matrix. So we'll have first number times first number plus second number times second number, which gives us 0. And now we'll do the second row. For element 2, 1, we're going to multiply the second row of the first matrix by the first column of the second matrix. So we'll do first number times first number plus second number times second number, which gives us 7. And for element 2, 2, we're going to multiply the second row of the left matrix by the second column of the right matrix. So first number times first number plus second number times second number gives us 2. And our last element, 2, 3, we're going to multiply the second row of the left matrix by the third column of the right matrix. We'll do first times first plus second times second, and we'll get 7. So the bigger your matrices, the more calculations you're going to have to do for each element in a product. Something to keep in mind here is that the number that both sets of dimensions share will tell you how many multiplication steps will go into the sum of a single element. Number 5 on your practice problems has you multiplying 3 by 3s together. So you're going to have a solution matrix with 9 separate elements, and each one of those elements is going to be comprised of 3 separate products added together. Let me know if you have any questions. Thanks for watching.